Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. In this lecture, we are going to discuss encryption. This is the last topic of your new section number 2 of the new syllabus. We have already discussed section number 2.1, data communication, and section 2.2, the packet switching and other things. So just this part was left, and we are going to discuss it and inshallah wrap it up in this lecture. So what is encryption? For those who are who are still following the previous syllabus, this part this topic was supposed to be in chapter number 8, security and ethics, whereas now it has been moved into the section number 2, or the second chapter of new book, new syllabus. So encryption is the process of converting data into coded message which can't be interpreted without a decryption key. It Encryption works just like a lock. You take your documents, your data, your information, and then you put a lock on it. And unless and until you have the key to that lock, you cannot access those documents or read those documents. The process of encryption is done through an encryption algorithm. This doesn't stop hacking of data, but the sad hacker is left unable to read the stolen data. Encryption is of two types: symmetric encryption and asymmetric encryption. Now, before we move along with the types of encryption, there is something which you should know, that is the plain text and the ciphertext. The examiner also often asks, so what is plain text, what is ciphertext, for 1 mark each. So plain text is the actual data that will go through an encryption process, means your data before going through encryption is known as plain text, whereas the ciphertext is the encrypted data that is produced by an encryption algorithm. And once you apply a lock on the plain text, when you apply encryption on this plain text, it becomes ciphertext, which is a code which looks like some gibberish or a string of different symbols and characters and alphanumeric data which you cannot read. Now, let's continue to the type of encryptions. In symmetric encryption, the same key is used to code and decode messages or data. This makes it vulnerable to hacking, as sender has to distribute the key prior to this to prior to or along with the encrypted message. Hence, a hacker can intercept it. Now, what happens in symmetric encryption? The sender, this is the message: may the force be with you. The sender applies an encryption algorithm on it, on this plain text, and it turns into this encrypted ciphertext. Now the sender sent this ciphertext along with the encryption key to the receiver. The receiver uses this decryption key and decrypts the message and reads it. May the force be with you. Now what happens is that when you are sending the log or the ciphertext and the key together in the same message, then if the hacker intercepts your message, he will have the key to open or decrypt the message and read it. This is a very big advantage of symmetric encryption, that you have to use the same key, hence it can be intercepted. So for that reason, asymmetric encryption was developed. This process requires two keys, a public key and a private key. A public key is distributed generally, while the private key is kept secure by the computer. Whenever a network or a communication is established, then at that time public key is distributed to every member in the communication. The sender encrypts the message to be sent using private key and then encrypts the key using public key. Now, when a communication has to take place, when one person on the network has to send a message to another person on the network, he takes the message and encrypts it using his secret key or the private key, and then encrypts the key using the public key, means using his the public key that was given to him when the communication was established, he encrypts that his private key as well. Hashing algorithms are used to encrypt the key or message, which are one-way non-reversible algorithms. These algorithms are one-way, they are known as one-way algorithms because they cannot be reverse engineered. The encrypted key and message is then sent over to receiver who uses his public key to decrypt the private key and then use the decrypted key to unlock the actual message. Now, when the receiver receives the package, what he does, first of all, he uses his own public key to unlock the private key that was sent by the sender. And then on using that private key, the user is able to unlock actual message which was sent to him. Even if a hacker intercepts the message, he would only get an encrypted message and an encrypted key. Since the hacker would not be having a public key, he would not be able to decrypt the key and use that key in order to decrypt the message. That is why asymmetric encryption is more secure than symmetric encryption. Here's a diagram of how it works. The sender converts the plain text data using his public key into ciphertext data, and then that ciphertext data and that private key is sent to the receiver. Now the receiver uses his public key in order to decrypt the plain text data, and that is read by the recipient. There are different models of it, but in general this remains the same. Sometimes the public key is used to encrypt the message and that is locked by the private key, and so on. But this is basically a simple diagram to make you understand how asymmetric encryption works. The sender sends some data. The sender encrypts the data using his private key, and then that private key is locked by the public key. And they are sent over to the receiver or the recipient. When the recipient gets it, then he uses his public key in order to extract the private key of the sender, and using that private key, the recipient is able to decrypt the message and read it. I hope you have understood. If you have any problems, feel free to contact me. Take care. Allah Hafiz.